Good morning, everyone. Welcome to this session, Dot into anything with type providers. So just very quickly, so I guess a lot of my career I've worked with sort of the data sciencey type people. Like I've often worked with people who, I don't know, they're really, really smart people. Sometimes they're only just tethered to the real world. They might lack a little bit of discipline, and you politely got to put it, or restructure things behind the scenes and make them look like rock stars, more or less. In the finance world, they're known as quants. In the rest of the world, they're data scientists. And just about dots, it's just a little bit of prose. So I mean, you might think it's the end. You might think it's a full stop. It's a piece of punctuation that ends your sentences. It's absolutely not. If you thought those things, you're wrong. Because, as Kandinsky says, everything starts with a dot. You put your pen on paper, you start drawing, you're drawing a character. Anyway, it's just a reframe, really. It's not necessarily true. And then you've got an exclamation mark, a little dot down the bottom. So things unfolding from an origin, the Big Bang. Anyway, there's a bit of a three-dimensional thing going on there, which we'll get back to. So in Linux, we've got the slash. So they've changed it on us. Oh well. But it's like exploring a namespace or a space that we're interested in. Hey Joe. So why a type provider in the first place? It's really a very simple device quite often. It's just a way of reducing friction. And we've sort of covered the discipline aspect. Just sometimes, I mean, some people are very immediate in the way they approach their work. Like mathematicians, they got an idea, they want to work with it, they want some data very quickly. So how do you get that to them quickly? And in a lot of environments, it's kind of, I feel like the type provider is just one more step from where people already are. They've got a large object model. An architect has spent a lot of time putting that together. So why not just go that extra step of providing a type provider? I haven't actually. So a really simple example. Go into, oh dear. Spoiling things a little bit there. So get into some code. It's just got the, in F#, you've got this reference type thing. Oh. That's, so maybe that's, so that would be this guy. So flip out. Yay. All right, so bin, debug. So we're just pathing into something live in the environment. This is actually probably not necessarily a type provider behind the scenes, but a type provider could just walk through a file system. It's pretty dull, pretty ordinary, but just a quick sort of an example of what we're talking about. And you know what? I might just, no, current slide, there we go. So it could be more elaborate. Upstairs, there's a company called SmartBear. I had a quick chat to them. They've got no idea that this even exists. I tried to tell them, but go have a chat to them. So they've got a RESTful API. There's actually a Swagger-based type provider. So it will automatically generate code for the REST-based calls that you need to make, and from there, you might wonder. So is our type providers a .NET only thing? Type providers are now supported on .NET Core. I think it's still a little bit edgy. You probably want to stay away from them a little bit longer on .NET Core. the example that I've been working with, I actually went back to the mono-based stuff because I've been developing on a Mac. So mono and standard, I believe it is. I need to talk to a sort of packaging expert actually at this point. But it's looking pretty good and it's pretty encouraging. So moving on, it's more into the reasons why you even why you care about these sorts of things. And it's sort of I kind of believe in a concept of notation as a tool of thought. You should be able to read the code. It should be self-explanatory. You should be able to sit down with a business user and they should be able to sort of see their algorithms expressed in a way that they understand, or with a little bit of explanation. I don't feel like that's always the case in C#. Possibly that's mostly idiomatic. But idioms stick with a language, whether the features are there or not, unfortunately. It's just one of those things. Anyway, there's Don's meta paper, which is pretty interesting. So it's just as a reference, I didn't really want to read through it that deeply. I'm not going to try and flick to it just now, but it's about meta programming in general. In the references section, there's a section to APL, and we discover that these ideas are actually quite old. And there's like a 1978 reference there. And it's really, I suppose, it says maturity. So, I mean, they're good ideas, basically, and it's a response to heterogeneous environments. You either go the polyglot route, which is, you just learn every language under the sun, and it's kind of, I think it's fun while you're young, and bright-eyed things, pretty much. And I think that at some point, I feel organizations need to see code as an asset, and it's nice to have a single environment, a single language, or a couple of well-chosen languages. We need to make some decisions on these things. It's kind of, that's my feeling. So one day, I was a bit confused after the financial crisis, and just kind of like, what is it I do? I've been in like several different industries. So I asked my 5-year-old daughter, what is it I do? And she answered, she looked up to heaven and took a breath and looked at me and said, "Daddy, it's like this." It's like you've got a magnet and you use the magnet to attract some numbers, you do some work on the numbers, and then you send them off. I thought, okay, that's not too bad. I can work with that. So, if basically we had a really nice keynote the other day, and we're talking about all the different encodings and so on. It's just, I kind of would go on and say, the set of natural numbers, we map that to the universal set of symbols, and then we can, that's just the way people do. They encode things and we work with these ideas. Anyway, I like my daughter's definition better. So anyway, girls rock, basically. And if we go on to Elon Musk, he did a ill-fated interview recently, which affected his share price quite badly. But I don't know if you caught that. But so Joe says, on Wikipedia you describe it as a business magnate, and Elon replied, "I prefer magnet," which is not too bad. I mean, magnets are important, and that they're fundamental to generators, and we're going to be talking about generative type providers. So on that note, I was going to hear a quick word from Dave Grohl, and it's just a song, really. So just as a quick interlude, we're going to skip actually that one. Like that song as I do. It's basically Dave Grohl's drum beat, which is pretty awesome. Oh, that's no good. That's no good at all. So Joe will be able to answer me better on this. C# is becoming more and more functional. There are lots of interesting functional features coming on. So this is not as true as it was, but I think Dave Grohl's drum beat, a lot of musicians from that time say killed hair metal from the 80s. So just have it, let's just savor that drum beat for 1 second. So that's so good. And then, when Dave was later working out what he's going to do with his life, he came up with songs like this.
This is embarrassing. Chicks dig it.
Anyway, I would like to keep listening to that. About a minute in, there's an awesome riff. Anyway, I'm an ex-guitarist, you might be able to tell. Here we go. So back into, so the generator lyric, I'm a generator, firing whenever you quit. Yeah, whatever it is, you go out and it's on. Can I code be that solid, that reliable, that useful? And then back into why you came. So Data 61, Adrian Turner, often he's got a bit of a drum beat. He's talking about organizations becoming data-driven. He talks about competitive advantage and so on. He puts it far more eloquently than I do. But there are companies becoming best of class, and we often will go into talking about machine learning, and you've heard the speeches many times, and I'm just really talking about a very, very simple thing of making those people productive. So the Kaggle survey from 2017, so it's still current. Essentially, when it comes to data science, there's just a lot of, it's kind of a running joke, basically. The amount of legwork that people have to do to collect data, collate it, clean it. Anyway, type providers are a response to this, not a popularly acted upon one as yet, but it's something that I think is growing. So I mean, just the whole data science thing. Bono once said, "You two are what happens when 3 musicians and a dyslexic get together." He being a dyslexic. Just different kinds of people. We just got to facilitate them. And we're not all engineers. We don't all think logically. And just because you don't think logically doesn't mean you're not smart. Doesn't mean you don't have a massive contribution to make. That's been my experience. I've worked with some amazing people. And just as a proxy to the rest of the world, mathematicians are often said they do their best work before 30. Should we be wasting their time? Should we? I mean, you see the bright young things in the workplace. Sometimes the running joke in an organisation is, "Oh, that's a job for the intern." Yeah, it's kind of "Oh, we need more interns." It's just there's some amazing processes that happen, and it's maybe not the best use of time. So we're going to get into the code, sort of show me the code. Type providers from the ground up. So what are type providers made of? So let's see, we flick and will it show us the code? Yes, we see some code. So here's a very quick thing. So this B type is basically a static type that's been created behind the scenes. We've got a get CSV, and down below we've got a little, a very simple 3-row thing that's been iterated over and is now displayed and usable. Then this is pretty basic, but different properties. We've got a method down the bottom. So I'm not maybe so down the bottom here. I should explain it. I'm not sure. Can I have a quick show of hands? Has anybody used F# here before? 1, 2, 3, 4. Okay, we've got a few. Good. So this is a REPL-based environment that we've got here. I should have explained. Up top, we've got a script, an FSX as they're called, in F# speak. And down the bottom are the results of the REPL. So just get rid of that as well for now. So I'll just go through that quickly again. So we created the type just here.
You might need to make the font a tad bigger, maybe for the people at the back. I can just read it. It's better.
There we go. Is that right? Okay. There we go. And then we're executing this line, which is not very well named, but it's just simple examples. We hit it, we get an execution down the bottom. That's an array. Down the bottom, these I've got these ligatures things turned on. They're actually not, they kind of go, what's that character? It's actually 2 of those. Can you see that? So a square bracket and a pipe, essentially. Anyway, just different examples. We've got static methods being created and so on. But more or less, if we go back to the OO world, as TypeProviders mostly emulate OO, you could probably do your creation of functions and so on, but idiomatically, again, I mean, that's it. The idiom is probably the most important thing at this point. The way they're used is a way of dynamically creating types. So nothing that earth-shattering in terms, so far, it's all very familiar. So just a few things about these so we'll go back into the slides just quickly. Let me turn it back on. We didn't cover the entry point, but we'll come back to that when we go back in. So classes, basically, it's associated with set theory, basically a collection of things. What are the things? Analogous to a rose tree, which if you're computer scientists, we're all probably professional programmers. So a binary tree, you've got a left and a right side, you traverse the tree. Rose tree just is something with many members, and then each node you can branch off. So just quickly, who's delved with reflection here? Yeah, Joe, obviously. Just a little. Yeah. So interestingly, and this is kind of a little bit surprising, it's kind of, sometimes if you've worked with Entity Framework, you look at these monstrous inheritance hierarchies, and it's just, oh my gosh, who put this together? But then you kind of look through it, and sometimes you see these little gems, and you go, you see them, and you go, this is why object-oriented programming exists. This is really nicely expressed. So underneath all of these different member types, there's a class called member-info. It's a little bit surprising because so these little, the colon arrow is basically casting to something at a higher level in the hierarchy. So a provided type definition, which is just a type, basically it's a type we're going to generate. It comes from type info, which then subsequently comes from member info. So it's kind of, we've got this hierarchy and everything's related. Provided methods also, constructors, fields, and properties. So I mean, that's everything that a type is made of, right? The surprising thing for me, it's not a surprise now, but when I was first investigating this, was that, oh, types are also a member. So which then goes into the definition of inner classes. Inner classes, everyone is familiar with inner classes here, or I probably shouldn't phrase the question that way. but and inner classes, you've got a namespace, but within the class itself acts like a kind of a namespace, and you can define new classes within that class. And that's kind of where that three-dimensional idea comes from. It's like, you know, you have this makeshift namespace that's just been created on the fly. You've got small members in it. You've got small members again. Thank goodness we don't have multiple inheritance to think about, just because I can't picture that in my head. But I can picture single inheritance, okay. But anyway. So that's just really just a little bit more about inheritance. So when we're doing provided types, there's another little surprise there, which turns out to be quite useful. And I don't know whether this is true in C#, so I've never actually tried it. And I don't know if it's true in the F# way of composing classes either, but within type providers, you can actually inherit, it's called a data backing store in this case, from any structure, any arbitrary structure, including tuples, which is probably a little bit disconcerting, but it's quite convenient once you get into the definitions of these things. We'll stop there with the slides. We're going to just check here. Get rid of that. So I just wanted to dive into the code at this point. Yeah. Okay, so type providers, and we'll go through the slides in a second, but type providers it's kind of interesting. Don Syme has done, he's always tried to bridge this gap between C# and F#. He's tried to make the F# features usable from C# and vice versa. He's done a great job. So sometimes his programming style, like certainly in his type provider work, resembles an object-oriented approach, which, I don't know, I've been out of the object-oriented space for quite a while, so I find that a little bit disconcerting. So I had to go ahead and undo that a little bit and use a feature called functional application, which basically just drop in commas and brackets and makes them a little bit more flexible and easier to work with. But the reason I did that was mostly so that I could resemble the way that you think about types and classes in C# or even F#, just the way you have like a static constructor keyword at the beginning. But anyway, let's just get into the helper functions very quickly. Oh, thank you again. So, that's cool too. Sorry, should have had that ready to go. Sorry about that. Now this code does need to be tied up a bit. I've just sort of had it as I'll just show you the project structure. Because I basically feel like the documentation around type providers needs to get a lot better, and the examples need to be a lot better as well. So I've wanted to have a ton of projects with, you know, all these different types of, or ways of working with expressions and ways of building these things up. So back to the helper. So essentially, got a bunch of definitions, a constructor, a field, a method, a property. There's a little bit of probably getting a little bit too terse here, so I probably need to expand that out a bit. But the G just stands for a getter and a setter, or an index getter. Anyway, this down below is typically what you'll see in a type provider definition. Is so you provide a property, you've got a name, a type, and a bunch of other named properties that you can play with. I wanted to simplify that. So going back to an example, and this isn't the best example, and I do apologize for that, but you're just dealing with a field and a name and a type, and that's it. If you want it to be static, then you do static in front here, and that's and then they don't support static fields in TypeProviders, do they? So a static method. So I don't know. I mean, it's just a namespace way of doing this. I don't know. That kind of, if you're doing a lot of this kind of thing, it kind of makes sense after a while. So there's that. Get rid of that. Back to normal. So this idea of sort of in a generative type provider, I mentioned this idea of a tree. I mean, there's lots of the examples out there. The structures involved are quite flat. The things that we're traversing across and creating dynamically, with the exception of the Swagger type provider, which is incredibly useful. So basically, when I put this talk together, I came up with far too much material to present. So I've really I've focused it in on quite a complex example, and that's to do with so first of all, hands up, Cosmos DB. Who's familiar with Cosmos DB? Yes. It's so a better version of that, if I can be contentious, is something called KDB Plus from kx.com. Essentially, a way of accelerating calculations, and you've got a relational database and time series and streaming and all this stuff. Anyway, basically, at the end of the day, you've got an AST that you're working with, and I just want to show you that very quickly. It sounds very too much to deal with, but this is the AST. We've got a few different constructs. We've got a list. We've got a bunch of things that are primitives down to about here. And then you've got a bunch of things which are a vector. And then built with those primitives, you've got tables and dictionaries and other things that you're already familiar with. So, and this idea of recursion, we keep coming up with it, dealing with it again and again. So we've got, I mean, whenever you do serialization, we're recursing over these structures, putting it onto the wire, taking it off the wire, recreating the structures. But that's roughly the same thing we're going to do with the type provider as well in a moment. So very quickly again, so back to, so I've just done this as a script at this point. Some data. That was the recurse 2. Here we go. So I thought that a simpler way to actually show the results of recursion would be just to actually just output a string, because we're kind of the type providers can become a little bit mysterious, I suppose. So very quickly, if I were to execute this, so recurse 2.2, here we go, sorry. So open this up, reset the REPL. So in this approach, it's I suppose there are some main steps. We'll just go back to the slides quickly. In all the type providers, you either got a spec, which is provided for you. In the Swagger example, you've got a spec. You refer to the specification, and you know what the structures will look like. Or you can infer what the specification would be like in the CSV type provider. You can look at the columns and you go, well, that's obviously an integer because there are no strings in there. or you guess, you don't know for sure, because maybe it's just, maybe you're just lucky it's the first 100 rows or whatever it is, so you increase the data set or whatever. This one's temporal, it's a date, this one's, a floating point. I mean, that's kind of simple, and we've probably seen these in, so in this one, you could use the return data as the specification itself and infer based off that. So that's what this first section is doing. Then this pipes across into this project to a string, so we know what it kind of looks like. Anyway, so I'll just show you the result of that. Oh, I just killed it. There we go. 1, 2, 3, and so very quickly. So I should put that back up to 300. Essentially, how to unpack the recursion. There's kind of a nice algorithm behind this. This is this infer spec thing. You're going to see this list. You've got dictionaries. A flip is basically a table in KDB speak. There's a mathematical sort of reason for that. You're kind of inverting like a dictionary of vectors, and if you flip them, then they become columns. So it's kind of there's a nice kind of mapping between those two things. And I'm just producing a specification for each of these things that we encounter. So we're traversing this tree, the AST, and producing the spec, basically. And then there's a bit where we're producing project a string, which is we're going to each of these nodes, and we're saying what that should look like. And that's this here. So yeah, sure, go for it.
So if I'm getting it right, so before you have this CSV, right? It has a bunch of data.
Mm-hmm.
And then what I think what you're trying to do here is like from that data you analyze this is a string, this is a string, this is an integer, but
Mm-hmm.
then you have this generator that kind of extract like yeah, the first one is a string, the second one is a string, the next one is integer.
Yep.
And then you create this generated class in F# or whatever it is.
Yeah.
And then you can use that to dock into each of those things.
Totally. Yeah.
But that's the TypeProvider.
Yeah, that's the TypeProvider.
But is it generating it on the fly?
It's generating on the fly, yeah. Subsequently, you can link that up to compiled code. And yeah, I mean, that's basically it. It's a bit behind the scenes to make them work. And that's kind of why I want to follow up with, like, I don't know, I run the F# user group in Sydney, probably going to run them quarterly, but just come up with additional online teaching material and documentation. It's not I don't believe it's as hard as it sounds. I haven't done a great job of explaining the recursion. Essentially, I was going to go through, well, I'm going to go to the board quickly, and we'll maybe dig into a few slides, but we just imagine each node as a dot. And here, we want to create a type and members, and at whatever depth going down this way. Essentially, so just going to generics really quickly. So you've got some type, I don't know, social class. So actually class up here, so class, and that might have a type. So if we recurse down, we go to here, and we see the members. So in most of the literature, you use, I think, depth first search, and we come back. We only know what the members will be completely at this, once we've traversed and explored all these things to here, at which point, because we need to know, like say there's a row that we're going to iterate over and that has properties, the only way we can define those is if we know this T ahead of time, and then we discover, oh, to have that T, then that definition needs to be here. So there's a little bit of, we create a definition and then we shift it back to this point here. So it's like a two-step create definition, and then that's what this, if you remember at the top level, I had a left shift functional operator, and that's what the left shift was doing, was just moving this T back to here so then we can create the class. And that's really the only headache. So it's really a two-pass sort of a process. Beyond that, it's quite a dynamic mechanism. So let's put that. I heard a rumor that C# is actually going to get type providers support, maybe be able to write them natively in C#, at which point I'll need to reevaluate what the best sort of deployment story is and so on. I still feel that there are some advantages to expressing things in F#. So with F# being a CLR-based feature, mechanism, whatever you want to call it, once you get to compiled code, I think you can access type providers through this. I mean, there are a few, let's be honest, there are a few rough edges, and it'd be nice if they weren't there, but they are fixable. And so the question was again, Joe, sorry?
Is there any way we can use that from C#? Is there anything we can do now to get through some type providers?
So the SDK, the mechanism, I haven't done this, so I can't say definitively, but it looks like you can create these provided type definitions from the C# code base. Looks like. The compiler sort of interactive mechanism which lets you live code against these things, so you can use the information, but can you live explore from C#? At this point, that's not possible to my knowledge. But once you've done the exploration and you bring the data back, you can access it through C#, because essentially, if you go down the path of deploying this, these specs get stored in a directory, and you've got little tiny assemblies which get loaded in. So theoretically, and I haven't done this from a C# perspective, I'd like to explore this more. You can load these little tiny assemblies in and just code against them as you normally would.
Generated at compile time as assemblies, in tooling time, you actually run the IDE?
That's the story I'm not completely sure of at this point. I need to explore that more. There are experts in the F# community who would be able to say it definitively. Yeah, it's sort of like a well-known location, and there's some ongoing work with the .NET Core is where that well-known location is, because we're now talking about Mac OS and things like that. So there's some changes going on. And so the talk that I wanted to do was, look, here we are on .NET Core, and we can do this on any operating system. I did have a lot of stuff running on .NET Core, but at some point I got frustrated with the project system, and I just thought, you know what, I'm just sticking with Mono, and I think it's .NET Standard. So I'd like to talk do you know about this more, Joe? There's this type forwarding mechanism that's going on behind the scenes, and I feel a bit uncomfortable with it because I don't know exactly what DLL we're pointing at, and I suppose that's just my own hang-up. Anyway, I've got a little bit of settling with a new way of doing .NET before I feel comfortable with that. I don't feel, I don't know, it's just there's a lot of change going on with this whole .NET Core thing. If you're doing just .NET Core, if you want to support different frameworks, and I don't know, we're all going through it, I guess. I mean,
So I don't know much about TypeProviders. Can I ask you sort of a general question?
Yep.
Which is when you, assuming that this schema is generated dynamically, that means that you could write some code, and then if that schema changes, your code no longer would compile. Is that correct?
That's correct. So there needs to be a versioning story. Perhaps you build that into the pointing mechanism, which might be a string pointing to the RESTful, the Swagger API, so as part of the string. So yeah, it needs to be taken care of. So yeah, but if you're in a dynamic environment, sometimes that's desirable though, right? So I mean, and that's kind of one of the nice things about F# scripts is the compiler / interactive environment will show you where the issues are. So, and you can get warnings and so on. So if you've got an architecture team who haven't quite settled on their final canonical layout, whatever that's going to be, it's kind of nice that the scripts break. You know, I want a warning, and I also like the F# environment as well. So I like the idea that you can have just. I haven't touched. Now Joe's the expert on the C# scripting side. I played with it quite early on in the piece, and haven't touched it since. So I don't know how mature it's become. Probably it's a lot better when I first touched it. But when you're in a type-safe language, it's nice to statically know. Like, it's nice to know ahead of time whether. Without, I mean, unit testing can be frustrating. You know, you can theoretically you can do anything with a unit test, but it's just nice being able to back. I think you still do need unit tests, but it's nice being able to back off a little bit and have the compiler do a bit more work for you. Like, here's a logical flow through the code, and the API changed, so this is broken. Something I want to know. So otherwise, you're in a Linux bash scripting kind of a world where you don't know until runtime. So there's that. Since we're on questions, any other questions?
Sorry, I don't do F#, so I'm not sure. Like with the TypeProvider, then is it like something like it will provide you with Intellisense when you dock it to something? Is that
Totally.
So is it like I think like if you use like Visual Studio Code,
Yep.
and say you have this kind of thing that generates like a class for you from this JSON object or something like that.
Yep.
And then can you kind of give it the source code, whatever, say your current code base. And I think with Omni Shop and stuff, you kind of get kind of the same. Am I wrong? I'm not sure.
Are you sorry?
It's like with Visual Studio Code, this right?
Yep. Which I've.
If you just like create your own class and stuff, and definitely now when like something does something, it will tell you like the Intellisense is there.
Yes.
So it's kind of similar.
Totally. So we're building into that mechanism, and that's part of the magic of TypeProviders. And I'll tell you the limitations in a second. But generally, for 80%, 90% of the use cases, you point at the TypeProvider, it goes off and spins up these schemas, so to speak, and then you just dot into them normally. It's just a normal coding environment. The limitations being, sorry?
So what scenarios then does TypeProviders give a benefit over Visual Studio and Intellisense?
It really just augments and enhances the. It just really builds on that mechanism. Yeah. If you've got an environment that doesn't change very much, then you don't need TypeProviders as such. But yeah.
So again, I'm still not sure. Is the TypeProvider itself looking at the data and then it change it regenerate the spec? Is that what it's saying?
Yeah. Yeah.
So once you run the TypeProvider, does it mean that you'll have more class files, like, I suppose not class files because it's F#, but type code in your code base, or is that kind of generated behind the scenes and the compiler, like Intellisense and things, are automatically able to plug into it?
So if you're deploying in this sort of this C# plus F# kind of world, and it kind of I often work in a scripting-based environment when I'm exploring. But if you follow the chain of events, this is something I should know more about. But the answer is yes. It basically creates it in assembly the same way C# would. It's IL at the end of the day, intermediate language code. It just loads it in just like any other assembly. Yeah. Sorry.
I asked before what happens if it changes, and you said it causes a compile time error, which is arguably a good thing.
Yes.
It's better to get that than to get the file at runtime. But what if the schema changes at runtime? Does it rebuild? Does it reevaluate those at runtime? And if so, do you get missing method exceptions?
That's the story that needs to improve, because I like distributed systems and I often work in this environment. So I think it's mostly an IDE issue. So I've kind of experimented with this quite a bit. So like at the command line, I know something's there, I dot into it, because it's kind of interesting on the command line, just like a Linux command line, I can create the FSI environment and I can dot into these things. What we need, I think, certainly for Rider, which I've been using in the last few months from JetBrains, is a cache invalidation mechanism, because the way the IDs are actually usually created, and this is me guessing and based on experience, is that they don't expect things to change. So it's mostly that the cache says an old version of information is there. So I just would restart the IDE, but I made a feature request on this on this point. Maybe Joe will do something amazing with LinkPad and like a very localized cache invalidation. So if something, it can get confused. Any other questions? But mostly, so real-time environments, this question actually bothers me, so I like real-time environments quite a lot. In a real-time environment, there's no reason why it shouldn't be able to create a new spec and let you continue on happily. There's no reason why that shouldn't work. But yeah, question of resources and so on and prioritization. But yeah. So, what time is it? How are we doing for time? 12:30. Do you want to just continue on for another 5 minutes, then break for lunch? Yeah, cool. Any other questions so I can maybe address them in the...
So one question.
Yeah.
So you're using this in your job, for the quants and for the exploratory stuff, is that true?
So KDB I use.
Yep.
I was part of a startup. We were quite I got to choose what happens. Depending on what my next role is.
Yeah.
Yeah.
Can you give an example of where TypeProvider has given value to your quants and to your data scientists?
Well, really just flexibly being able to pull up a data set and work with it. I mean, it's quite a simple mechanism if you kind of break away from it. I mean, at the discriminated unions, I'm not sure if you're familiar with those. Well, pattern recognition is a C# feature, right? So casting to a pattern based on something you're expecting is not such a bad thing at the end of the day, but it just shaves a little bit of frustration and time off the thing. Like maybe you've got several servers. The first step is which server am I talking to? Next step is I want to send a query to that server. That choosing of the servers could be a type provider. It's I don't know. It's kind of with the part of this talk. I mean, I could have taken the talk in terms of a survey of all the different type providers that are currently available, and I chose to try and stay a little bit more specific. Can't answer that question definitively.
So the value to your users is around improved tooling, less friction in the tooling.
Less friction, essentially. That's the way I see it.
Especially with exploratory stuff.
Exploratory, definitely, and things that are changing on a daily basis, or certainly not every minute. But I'm too mind on that. It's just like, oh well, I'll just restart the IDE. There's something new out there which it's not recognizing. But I don't mind that too much at this point in time. In the future, if this feature goes mainstream, I think that's something. That's for me. I mean, I don't. Yeah, it's sort of a scenario of what this was designed for. It's like something that changes semi-regularly. I think that's mostly what people. Their kind of paradigm, but I'd like it to be more immediate. Yeah. Anything else? Yeah. Yeah, cool. Okay, so I might just see what else I had on the slides and just sort of quickly. So this goes to Joe's question quickly on the. There's this concept that it's kind of some weird words. Like there's a word erasure. So the class being the enclosure. What happens if you're in an environment that doesn't have any idea of what type provider is? Then there's this erasure concept. Anyway, I've been getting a little bit too creative, but it's essentially a structure that C# would understand without the type provider mechanism, if that was needed. So we've looked at the examples. This is a bit more specific in terms of a really central feature for type providers is the idea of an expression.
Sorry, can I interrupt? So you're saying that there is type erasure or there's not type erasure with type providers?
Again, I do generative type providers. I've not explored the erasure mechanism. I usually, when I'm building one, I'll create it so that there will be an erasure, but it's an extra. If you want an example, check out the CSV type provider by Thomas and Gustavo, Thomas Petracek.
But surely by reflecting over whatever type it is that you're consuming, you're still going to have those properties.
One would think.
So you think
Yeah.
It'd be almost, well, actually that would depend how it's implemented. But I think that the default would be no type erasure, surely.
That's the way I always go. I haven't quite understood why you need an erasure. I need to talk to Don or something about that. Yeah, I would agree with you. So kind of what's the point? What's the point of having an erasure in the first place? Possibly it's to do with, so an FTP type provider, if you're stepping into a namespace that could be infinitely large, which is one of the things, so that there's this lazy implementation where you can only go and get the extra time, only go get the information if you need it. So I mean, there's more to type providers, but yeah. Anyway, central is the expressions, and then I was going to dig into how you piece an expression together, but some of really just on features, probably an interesting thing, evolution of type providers is that you generate a type, but it's available to C# or F# in any normal use case. Like you might have, anyway, you just do a class of type T where this T is a provided type, and just use it just as per normal. That's currently not possible, so you'd have to generate the whole thing. But anyway, that's kind of all I've got prepared, and thanks very much for coming. So, yeah.